It's 3:30 in the afternoon. You're staring at your screen, and somewhere in the middle of a sentence, you realize you've read it 4 times. The words are there. The meaning just isn't landing. Most of us know that feeling, and most of us blame the usual suspects: bad sleep, too much caffeine, a schedule that never lets up. We call it one of those days. But here's what that framing gets wrong. Your brain didn't get tired. It made a decision. A calculated, resource-based decision, the same kind any smart system makes when supply drops below demand. It found the biggest consumer in the network and cut power there first. And your brain's consumption is extraordinary. Think about this. It's roughly 2% of your total body weight, and it claims 20% of all the glucose in your body, constantly, even at rest, just by being on. Here's the part that changes everything, though. Your neurons, unlike your muscle cells, can't store glucose at all. There's no reserve, no buffer. They need a continuous supply every second with no gaps. This isn't an organ that can run at half capacity. It either gets fuel or it starts rationing. And when it rations, it always cuts from the same place, the prefrontal cortex. The part of you responsible for working memory, focused attention, and the ability to hold a complex problem together without dropping pieces of it. There's a precise biochemical reason this happens, and it's not about willpower. Let me show you exactly what's going on at the molecular level. Every meal triggers an insulin release from your pancreas. Insulin's job, its only job, is to act as a delivery signal. It tells your cells to open up and let glucose in. Under normal conditions, a protein called GLUT4 moves to the surface of the cell. The gate opens, glucose enters, and your mitochondria, specifically a protein called ATP synthase, spin up to roughly 100 revolutions per second. That's what it takes to produce ATP, the only energy currency your neurons will accept. But here's what happens when blood sugar spikes repeatedly. Year after year. Insulin gets released. Glucose is sitting in the blood. GLUT4 doesn't respond. The gate stays shut. Imagine thousands of fuel trucks idling outside a warehouse, engines running, horns going, while the reserves inside run dry. Not because there's no fuel in the world, because the mechanism that opens the loading dock stopped responding. That's insulin resistance. And the cells it hits first aren't in your legs or your liver. They're in your brain, in the one system that can't afford to wait. Researchers at the University of Oxford looked at data from more than 37,000 adults in the UK. No dementia, no prior stroke, no neurological diagnoses. Among those with metabolic syndrome, a cluster of at least 3 cardiometabolic conditions, the brain scans told a different story. Working memory was measurably lower. Processing speed was slower. Executive function was reduced, and their hippocampus, the brain's primary memory structure, was physically smaller. Not in sick people, in dementia-free, functional adults, before any diagnosis, and the damage scaled with exposure. The more metabolic markers a person carried, the greater the reduction in brain volume, and the worse their cognitive performance. Every additional component acted like a weight on the system. When the same Oxford research group followed 176,000 participants over 15 years, the trajectory became hard to ignore. Those who entered the study with metabolic syndrome faced a 12% higher risk of developing dementia. And when researchers looked only at dementia cases that developed 10 or more years into the study, specifically to rule out the possibility that early disease was already silently underway, the association grew stronger, 22% higher. No pain, no warning. The process was already running. But what if those toxic plaques aren't the starting line? In early 2026, a review of 64 studies reframed the sequence entirely. The metabolic disruptions, reduced glucose uptake in the brain, mitochondrial dysfunction, insulin resistance, often appear before significant amyloid accumulation, before the hallmark proteins that show up on a scan, before whatever eventually gets a name in a chart. The researchers described it plainly. The evidence supports the hypothesis that this disease may originate from cellular metabolic dysfunction years before symptoms emerge. That 3:30 moment? It's not weakness. It's a brain running on a disrupted energy supply it never told you about. But here's where the story becomes something you can actually act on. This isn't a life sentence, it's a diagnostic window. Because while the research on brain impact is alarming, the clinical data on what changes cognitive function is equally clear. We're talking about 133 systematic reviews, 250,000 people, across every age group studied, a 2025 umbrella meta-analysis in the British Journal of Sports Medicine pulled all of it together, nearly 2,700 randomized controlled trials. The finding was consistent. Physical activity significantly improves general cognition, memory, and executive function, even at low intensity, even in interventions as short as 1 to 3 months. So what does the data actually say to do? 2 protocols, both backed by clinical evidence. First, break up the sitting. When you sit for hours, the contractile activity of your skeletal muscles drops. Your body's ability to regulate blood sugar drops with it. A meta-analysis of 7 acute trials tested what happens when you interrupt that. Standing breaks did significantly reduce post-meal blood glucose compared to continued sitting, but had no significant effect on insulin. Light-intensity walking did both. Short bouts of walking significantly reduced both postprandial glucose and insulin, proving to be a superior intervention. Because walking triggers a contraction-mediated pathway, one that pulls glucose from the bloodstream independently of insulin. This mechanism is associated with preservation of pancreatic beta cell function. Not a gym session, not a step count target, just movement interrupting stillness. Second, change the sequence of what you eat. You don't need a different diet. You don't need to count anything. You just need to change the order. Researchers at Weill Cornell Medical College ran a crossover study with 16 adults with type 2 diabetes. Same meal, same calories, same components. ciabatta bread, orange juice, chicken breast, side salad. The only variable was the order. When protein and vegetables came first, a 10-minute pause, then carbohydrates, the post-meal glucose spike dropped by 53 to 54%. Insulin excursions were nearly 25% lower. GLP-1, a key hormone that slows gastric emptying and regulates metabolism, was significantly elevated. The researchers noted the magnitude of blood sugar control was comparable to targeted pharmacological agents, not a different diet, the same food, a different sequence. There's something worth sitting with here. The mechanism behind all of this is extraordinarily complex. Decades of molecular biology, hundreds of clinical trials, a full picture of mitochondrial signaling, receptor sensitivity, and glucose transport. All of that was required just to understand the problem. And what the research points to is, get up and walk and eat in a different order. That gap between complexity and simplicity, that's what real metabolic science looks like when it actually works. The next time it's 3:30 and the sentence won't land, you'll know exactly what's happening, and you'll know exactly what to do about it. If this kind of breakdown is useful to you, subscribe and turn on notifications. The next video examines what chronic stress does to your metabolism and why the damage is more measurable and more reversible than most people expect. Leave a comment with what you want us to decode next. We read them, and they shape what we research. See you there.